We are a team of 5 members from Albemarle High School in Charlottesville, Virginia. We've been doing the Kidwind Challenge for the past 4 years, and these competitions have given us a lot of experience, so we've learned more about base design, airfoil, and the types of blades that affects the amount of generated power. This year, we've decided to create an alternator using neodymium magnets and copper coils. When it comes to wind power, we know a lot about the concepts of wind, how it is used in the turbine, how it generates power, and wind farm siting.
Alright, so right now I'm building the base for the wind turbine. And this is what it looks like.
Yep, there's like tons of light. Right now we're putting together the back brace of our base to give it extra support. Right now I'm going to drill pilot holes for the right support beam.
Alright, go.
Our blades this year are based off of our blades we made last year. We first designed them on Adobe Illustrator to be laser cut, and each of these holes will have a dowel through them to connect them together. And after we have a frame, we will wrap them in heat shrink plastic to seal them and make them into an actual blade. This year we decided to curve our blades so that when they're curved, the end is spinning much faster than at the base, so it'll create less drag by being flat at the top instead of curved. And the way we curved them was we put them all on the stick and then put them on this little contraption and then glued them so that they're in a straight line at an angle.
So this was our template for our rotor before we started, and this is after we started. And you can see the result is here. We've got a big steel plate with all our magnets on it, and they're pretty scratched up. So what we're doing right now is building a coil winder. So you'll see that this will spin around on an axle, and what the point of it is that we're going to put this copper coils, and they'll wrap all the way around it. And this will create these coils that are going to go on something called a stator. They'll all be glued in place. There's 9 of them. And they will go around the magnets, and that's what generates electricity. To count the coils, we have this code here that's hooked up to our Arduino. And so I'm going to turn on this little monitor here, where you see right now it says 0. If I spin this around once, it turns to 1, 2, 3, 4, 5, because we have this distance sensor here that counts every single time it goes around. And that's how we're going to build the stator. Alright, so one of the improvements we're making this year is using this magnet with a reed switch instead of distance sensor. So our distance sensor measured the distance, but it wasn't very accurate and it couldn't go very fast. So if you look at this, I have an Arduino set up here, and this is our port. And if you look here, if I place a magnet over this, it increases the number every time the magnet goes over the reed switch. And so we'll have this, the magnet on one end and the reed switch on the other, and when their coil winder spins, it'll count.
This is our new and improved coil winder. Compared to the old one, it is more accurate and only requires one person to wind the coils.
This is our new stator template. So our old one, you see, we had it to fit the magnet, so we had square-shaped coils like these. But our new one uses trapezoidal coils, and we have 9 of them, and these will go on top of the rotor, and we'll put them in each of the spots, and it'll spin around freely on the axis.
So we've put together our wires, but now we're soldering them so that it's more permanent, and then we're going to stick them into these rectifiers so that we can generate some power. Yeah. Oh, there we go. Yeah, I think we're good.
These rectifiers here that are attached to the heat sinks are important because they take the alternating current that is made by the alternator and transfer it into direct current.
So here I have all of our extra documentation other than just the video. So here I have a model of our base, and then I have a model of our alternator. So here's where the magnets go, here's where the copper coils would go. And then here I have a model of the coil winder, which is how we would make the copper coils that go in here. And then this is the contraption we use to make our airfoil blades into different elevations. And then we also have an Illustrator file of the airfoil, which I'm also going to print out just like this.